right there. We transplant this number right here. We end up with 12.6 divided by s squared minus 2 times a would be half, and since it's negative, it's plus 0.5s. Let's see. 1/4 squared is 1/16 plus b squared. I have no idea what that turns out to be. I get 1.642 when I do that. Like that. Questions about that? There are at least 2 other forms we could put that answer in, especially the denominator part of it. Numerator's pretty set. At the bottom of the denominator could be 2 other forms, and they would all be correct. The next says, find the system transfer function. What this means is we could go into the lab, put a unit step into a system, measure the output, and determine from that what the transfer function of the system is. If it's a simple enough system, then we can actually measure some things from the output. Isn't that kind of cool when you think about it? So one of the ways to get that transfer function is to do a sinusoidal input over a range of frequencies and then back it out of the Bode plot. Another way is to put in a step and see what comes out. And that tells us an awful lot about the system transfer function. And in fact, if we can measure that output as accurately as this, we should be able to get a good, reasonable transfer function. So, what is the transfer function? Well, here we need to know what the input is. But if this is the unit step response, what was the input? Is it just 1 u of t in time, but what is it in x of s? So, the transfer function of the system is what over what?
Over x.
Now I can write that as a division, but what's easier?
Multiply.
Yeah, just flip the x of s over and multiply it. So it's easier to think of this way. Like this, which means that it is this times what? Or if you like, times 1 over s. What's 1 over s? S. So can I put it up here? Now let me ask you, does it make sense that this transfer function has a 0 at the origin?
Yes.
Why?
It decays to 0.
Because it decays to 0, because the step response has no DC gain. It doesn't come out with a DC value, so yeah, it better have a 0 at the origin. And there it is. So it sounds like a complicated question, but it turns out not to be that awful. Does that answer your question, John?
Oh, yeah. Okay.
Go ahead, Eric.
On that same exam, number 3, well, different number 3. Not the one above it, but the one on the previous page.
Okay.
Just A and C on how do you, on...
You mean, is this the Bode plot?
no,
Transfer
it's
function?
No,
the
it's
Vivo
the-
stable, yes, no, I can't tell.
Front page.
I'm sorry. You have to show me which problem we're looking at. Oh, okay.
This part's A and
It's closed
C.
book 2E, right?
Yeah.
Okay.
How can we tell just by looking at it?
Okay, let me get the. Okay, I gave you something similar to this in, I think, the second exam?
Yeah.
Yeah, something very similar. In fact, it may have been lifted from here. Several transfer functions are shown below. Without doing anything more than looking at the transfer function, try to determine if it's BIBO stable. Answer yes, no, or can't see, when meanings can't tell just by looking. So this goes back to the Roth-Hurwitz stuff. And we can tell for sure that a transfer function has a pole in the right half plane if any of the coefficients in the denominator are what?
Negative.
Negative or
Missing.
missing altogether.
Yeah.
That we can tell for sure. If there are negatives or there are missing coefficients, we have a transfer function in the right half plane. But if they're all positives and it's a greater order than 2, we're still not entirely sure. But if the order is 2, can we say for sure that all of the poles are in the left half plane? Mm-hmm. Okay, good. So that's the general rule that we're looking at here. Or the set of rules, whatever. So the first transform we got here, first transfer function that we got here is S plus 6, S to the 5th, plus 4S to the 4th, plus 2S cubed, plus 6S squared, plus 2S plus 1. So you look, S to the 0th power, S to the 1st, 2nd, 3rd, 4th, 5th, all the coefficients are there, and they're all positive. So it looks good so far.
But there's order higher than 3, so you can't tell.
Yeah, it's higher than 3. So without doing more work, without putting this in your calculator or doing a Roth-Hurwitz test or something like this, you don't know for sure. So this is the one you say you can't tell without doing more work. So this is a C.
And that's strictly because it's a higher order than 2.
Yeah, so we can't say for sure yes, we can't say for sure no. If we can say for sure yes or no, we would put down a Y or N. The next one, S minus 4. Now, does that bother you right up front? What is there in the right half plane with that S minus 4?
0.
There's a 0. Does that necessarily make it unstable? It'll make it work wacky, but S to the 4th plus 2S cubed plus 1S squared plus S plus 0.25. S to the 0th, 1, 2, 3, 4. They're all there. They're all positive, but the order is greater than 2. So does this also? I can't tell? Yeah. The next one down. 10S plus 1 over S plus 2, S squared plus 2S plus 4 times S. Do we multiply this out?
No.
No. You look at each piece by itself. Because they're multiplied, you just get poles from each one. Is there a problem with any of these?
Yeah.
Which one? Last one. In fact, it's obviously a pole at the origin, which means what about the BIBO stability? So this is a definite no. Up here, S plus 1. S to the 5th plus 3S to the 4th minus 18. Do I have to go on any further?
No.
No.
It's a no.
Yes.
There's a negative.
There's a minus, there's a negative, that's obviously we got a problem. One of these poles must be in the right half plane, at least one. Let's see. S to the fourth plus 10s plus s on top. S squared plus 2s plus 5 times s squared plus 4s plus 4 like this. What can you say about that one? Again, do not multiply out the bottom, because that changes it from a definite yes to a can't tell. But can you tell this way?
Yeah.
Because there's two second orders multiplied by each other, as long as each one has no poles in the right half plane, the whole thing doesn't have any poles in the right half plane. So this is a definite yes, it's okay. The fact that there's a 0 at the origin does not matter. It just means that it doesn't have any DC gain, kind of like this system here. Finally, S plus 2 on top on the bottom, 5s to the 6th power, plus 13s to the 4th power, plus 8s cubed plus s squared plus s plus 2. S to the 0th power, 1, 2, 3, 4,
Missing 5.
missing 5.
So it's not stable.
So it's not stable, and we know that for sure. It's not BIBO stable. We have at least a pole on the J omega line, if not in the right half plane. And it's not an absolute case, but often when you're missing one like this, it means a pole on the J omega axis, and when you got negative, you got one or more poles in the right half plane. Typically, not for sure, but. Questions? Yes.
2012 number 6.